This is the 4.1 to 4.2 review, free response problem number 10, and calculators are allowed. So, first piece, we are given a function that is a piecewise function, and that piecewise function actually involves some absolute values, which means we really have a piecewise in disguise just for this branch. So there's really going to be three branches. We're going to have one branch when x is less than 0 and one branch when x is greater than 0. So we could, if we chose, rewrite this as three different branches. We can have the inside left alone over the inside left alone for all x's that are positive. Then it's going to be 2 when x is equal to 0, and then it will be the opposite of the inside over the log natural of the opposite when x is less than 0. So just to kind of keep in mind, we'll probably be working with one or more of these branches. So first question is, what is the domain of f? Well, remember the three problems of domains are if we try to divide by 0, if we try to put non-positives in logs, or if we try to do negatives inside even roots. Looking here, we see division, and we also see log naturals. So whatever's inside this log has to be positive, and whatever's inside this log cannot create a 0 when it comes out. So log natural of absolute value of x will equal 0 if the absolute value of x is 1. So that means x can't be plus or, no, should have said 0 and I put an e there. Log natural of absolute value of x will equal 0. If we e both sides, we'll get e to the 0, which is 1. So absolute value of x will equal 1 if x equals plus or minus 1. So that means our domain will be, for this branch, x's that are greater than 0 as long as x doesn't equal 1. And then when x is less than 0, it will be viable input because we're absolute valuing it. So the opposite of that negative number will still be positive, but we can't use -1 either. So my domain is all reals except for plus or minus 1. If we look at the point breakdown, you get 1 point just for writing the domain. Part B says, is f continuous at 0? And we need to justify. So remember, if in a free response you're asked about continuity, you have to write down what continuity means. So that would be the limit as x approaches 0 on the function values should be the same as whatever the function spits out when you plug in a 0. So if we come up here and we look at what comes out when I plug in a 0, it's a 2. So we need to figure out whether that two-sided limit, as we're approaching 0, is indeed 2. So if I look at it coming from the right, I'll be in this upper branch, which is 3x over ln of x. When I plug in a 0, I'll have a 0 on top, and I'm dividing by a very large magnitude negative number. So 0 divided by gigantic number of magnitudes will still be 0. Doing the same thing from the other side, I'm approaching 0 from the left. I'm still going to get a 0 on the top divided by a very, very large magnitude negative number. So that also will be 0. So my limit, which was 0, does not equal the output, which is 2. So no, f is not continuous at x equals 0. Okay, next part C, we want to determine the symmetry. Well, the symmetry we can examine by looking at the opposite of x plugged into f. If I plug that in, we'll just look at the original function. I will get the absolute value of 3 times a negative x over the log natural of the absolute value of a negative x. And notice that absolute values are going to strip off those negatives anyway, so we'll end up with the exact same thing as we started with. When that happens, we say that the function is even or has y-axis symmetry. Now the beauty of that is that now we can examine just what happens on the right-hand side and then use the symmetry to get what's going on with the left. So F is even, or F has Y symmetry. So maybe before we continue on, we'll do the point breakdown up to here. For the first part, we get 1 point for writing the domain. For the second point, we get 1 point for saying no and giving the reason, which is this definition and how they don't equal each other. So 1 point for that. Next, part C is worth 2 points. We get 1 point for saying that it's even, and we get another point for doing the justification and showing that f of negative x equals f of x. So a total of 2 points. So we have 5 points remaining, and with those 5 points we have got to find the coordinates of relative mins and maxes, or no, just mins, I lied, and we have to find the coordinates of the relative maxes.